All right, today we're going to look at lesson 4.4, scatterplots and lines of fit. Okay, scatterplots, exactly what they sound like. It's a plot with a bunch of points scattered on it. All right, we're used to 3 points, 1 line, but these plots are going to look a little bit different. Good news is we still plot points the same way. So our essential question, how can you use a scatterplot and a line of best fit to make conclusions about data? Well, what is a scatterplot? A scatterplot is a graph that shows the relationship between two data sets or data sets, however you say that word. All right. But if we're talking about a scatterplot and we're talking about a bunch of points, then how are we representing two data sets? Well, it's because your ordered pair of X and Y, the X represents one part of the data and your Y represents the second part of your data. So you're going to notice on these scatterplots that the X and the Y axis are actually labeled. All right, how do we know what the X axis represents? How do we know what the Y axis represents? They're going to be labeled, which means when we go to graph scatterplots, we are going to have to actually label our X and Y axis. So it's a little bit different than what we've done before, but not really. All right, let's look at example number 1. Now, we are supposed to interpret this scatterplot. So let's break it apart for just a minute. I didn't make you draw it in your notes, so you got to really pay attention to what I'm doing on the screen. Okay, first of all, you're going to notice your x-axis and your y-axis. You're only shown the positive y part of the axis and the positive x part of the axis. Okay, so notice that we're looking at one quadrant of a coordinate plane. So that's the first thing you want to notice. Secondly, look at the labels. The x-axis is labeled sugar and the y-axis is labeled calories. That's important because when we go to answer these problems, we've got to know if we're looking at the x-axis or the y-axis. All right, look at the way the axes are numbered. So look at the x-axis. What are the increments?
4.
They're counting by 4s. You got 46, 50, 54, 58, so they're counting by 4s. Now, do the same thing. Look along the y-axis. What increments are they counting by?
10.
All right, so here's another thing that's a little bit different than what you're used to. When we create a scatter plot, we don't have to count by the same thing on the x-axis and the y-axis. All right, we've got a little bit of liberty, a little bit of room to do what we want to do. All right, so notice that they're counting by 4s along the x-axis, they're counting by 10s along the y-axis. Now, let's go look at the question. Question number 1 says, how many calories are in the smoothie that contains 52 grams of sugar? So 52 grams of sugar. Yasmin, the sugar, is that the x-axis or is that the y-axis? So we have to find 52 on the x-axis. And if we do that, we're going to notice it falls right here. We're going to guess right between the 50 and the 54. All right? So the question is, for that smoothie that has 52 grams of sugar, how many calories is it? Well, I'm going to start right there at what I believe is 52, and I'm going to run my eyes. Okay, I'm going to look up the graph until I hit a point. So if I were to do that, right here is where I run into a point. Now, that's my x is 52. What is the y value, Yasmin, of that point that I just ran into? So the smoothie that has 52 grams of sugar has how many calories? 250. And that would be the answer to my question. The smoothie that has 52 grams of sugar has 250 calories. Now, letter B. How many grams of sugar are in the smoothie that contain 270 calories? So this time, the 270, Anthony, we're going to be looking at which axis for the 270 calories? Are the calories on the x-axis?
Oh, no,
The y-axis. So we're going to go up the y-axis until we find 270, which is right here. And this time we're going to look sideways, all right? We've got our 270, but we're looking for how many sugars. So if I follow my eyes across the graph, I run into a point right here. So the question is, Deja, what is the x value of that point? All right, she says 56. Would anyone, and if I go down from this point, I hit about right here, would anyone have said something different? Maybe 55, okay? And that's where scatter plots can get a little bit tricky. But here's what we're going to do. Since we're not exactly sure, since we don't have an exact number, we are going to use the word about. So Deja would have written about 56 grams. Amiri would have written about 55 grams. So there is going to be a little bit of wiggle room for you. As long as you don't say 42 grams, which is nowhere close to the answer, you're going to be okay. But we're going to use the words about if we cannot find an exact number on our graph. All right, so that's how we interpret a scatter plot. Now, let's talk about scatter plots and their correlations. This has a lot to do with slope. You remember when we learned slope and we looked at a line from left to right? If the line was rising, we called it what kind of a slope? Positive. If the line was falling from left to right, we called it negative. So look at correlation. Correlation is the relationship between data sets. So all these points on the same graph, what kind of a correlation do they have? So if you look at the first graph, this graph right here, what are those points doing as we move left to right? They're rising. So what kind of correlation does this graph have? Positive. All right, it makes sense. Look at this one. What are these points doing from left to right? Falling. So what kind of correlation do they have? Negative. And then look at this graph on the bottom. Are they rising, falling, or you just can't tell? They're all over the place. They're not rising, they're not falling, they're all over the place. So this graph has no correlation. None. No correlation. All right? So hopefully if you understand slope, then this is going to be pretty simple for you. Now, they are asking us to, in example 2, to create a scatter plot. So we're going to take our time. We're going to go through this. You make sure you get this in your notes on your graph paper. All right? Unfortunately, my graph is so small. If I try to write numbers, you're not going to be able to read it anyways. So I'm going to talk you through this, but on your graph paper, you should have plenty of room. All right? Remember, our focus is really going to be on this quadrant right here. This quadrant right here, because we are going to look at our positive y values and our positive x values. All right? So let's talk about our x values first. If we look at our table of information, we've got x values of 1, 2, 3, 4, 5, 6, 7, and 8. So what increment makes the most sense? Let's count by what? Ones. Why twos? Why would we do twos? 1, 2, 3, 4, 5, 6, 7, 8. I mean, they literally go up by 1. So let's count by 1, okay? We always want to count by 1 if we can, because that makes our lives much simpler. All right, so go ahead on your x-axis, number from 1 to 8. Now we have to label, what do those x values represent according to this problem? What does it say on the table?
Age of car.
Okay, the age of the car, or years. I would even take years as your label, but you got to label it. All right, years. Now, what about your y values? Look at those y values. We got 24, 21, 19, 18, 15, 12, 8, and 7. Now, my first thought is, do those numbers look like the multiples of a certain number?
Yeah.
Okay, they look. A lot of them look like a multiple of what number?
3.
3. Very good. So why not count by 3s? Could we count by 2s? Absolutely. Could we count by 5s? For sure. All right, but let's find the number that makes the most sense. And the most sense, the one that's going to help us get the most exact points, is definitely going to be counting by 3s. So along your y-axis, all positive, you're going to count from 0 to 3 to 6 to 9 to 8 to 12 to 15 to 18 to 21 to 24. Why to 24? That's the largest number in our y values. So count by 3s, and then we've got to label. What are we going to label our y-axis? Value, okay? Value. And let's do value in thousands. Because if we were asked to interpret this, it would be important that we know the value is in thousands. All right, I abbreviated because of space. If you can fit the whole word thousands, fit the whole word. All right, now let's plot the points. All right, Timothy, what is the first ordered pair on this table of information? 124. So we're going to go right to 1, and you're going to go up to 24, and you're going to plot a point. All right, what's the second Dalton ordered pair?
221.
221. So again, I go right to 2 and then up to 21. All right, what's our next ordered pair, Trevin?
319.
All right, now this is the first spot where we're going to have to be careful. We're going to go right to 3 and then up to 18. And remember, it's a 19, so we're going to go just above that 18 line. Just above it. All right, Noah, what's our next point? Good, so right to 4 and up to 18. All right, Amiri, what's our next ordered pair?
5.
Good, right to 5 and up to 15. Alonzo, what's our next ordered pair?
6 and 12.
So right to 6 and up to 12. Michael, what's our next ordered pair?
7, 8.
7, 8. So right to 7. And again, we got a 9, so we're going to go right below the 9 to plot that point. And our last ordered pair, Joshua?
8, 7.
8, 7. So right to 8 and just a little bit right above that 6 line. Now, the question is, tell whether the data show a positive, negative, or no correlation. So as I look at this graph from left to right, what kind of correlation does it have?
Negative.
Negative. So your final answer is negative. All right. Any questions? All right. Lastly, example number 3. We're going to create another scatter plot, but this time they want us to write an equation. That should be the word an, not and. Sorry about that. Write an equation and interpret the slope and y-intercept of the line of fit. So this time we're going to find a line and we're going to write the equation of that line. But let's start with our scatter plot. All right, look at your x values. What makes the most sense? Counting by ones again. All right, so go ahead. Again, remember, we're just focused. All of our x and y values are positive, so we're literally just focused on that quadrant. All right, what are we going to label? Oh, you don't know. I got to read you the problem that this goes with, okay? The table shows the total earnings y in dollars. So y actually represents our earnings of a server who works X hours. So the X represents the hours that this server works. The Y represents how much money they make, their earnings. The X represents the hours. So once you've numbered 1 through 6, what are we going to label the X-axis? Hours. Very good. And this is really important for this problem because we're interpreting the slope and the y-intercept. All right? Now, your y values. Y is a little trickier. You've got 0, 18, 40, 62, 77, 85, and 113. So they're all kind of like middle numbers. So what would be a good increment to count by?
20, 15, 10.
Okay.
20.
10 is what I've been doing, and 10 is working perfect. Is 15 wrong? No, but you're going to get points more smushed. Okay, so let's count by 10. So up your y-axis, count by 10s, and then what are we going to label the y-axis? Earnings. And then you can put dollars beside that if you want. But let's do earnings, and that's just money. If you aren't sure what earnings means. All right, let's plot the points. We have 0, 0, so that's a real easy one. Right there in the center. We have 118, so we're going to go just to the right one and just under the 20 and plot a point. 240, right 2 up to 40. All right, we've got 362, so right to 3 and up just a little above 60. All right, 477, so right to 4 and a little bit closer to 80. This is why if you make your increments too big, your points are really going to be smushed in there. All right, 585 should be pretty simple. We go up halfway past 80. Plot our point. And then 6, 113. So we're going to go right to 6 and just a little bit past 110. All right, any problems with the graphing? All right, now we have to draw a line of fit. So listen very carefully. We are going to draw a line that hits as many of these points as possible. It's not going to hit every single point, and that's okay. That's why it's called a line of fit. Does it fit onto the points, okay? It might not hit every point, and that's okay. So if I'm looking at this graph and I'm trying to draw a line of best fit, I'm probably going to try to definitely hit these 3 points, and then I'm going to keep my line going because it's a straight line. I'm not having to adjust and try to hit every point. That's why it's called a line of fit. It's not going to hit every point, and that's okay. And my line is supposed to be straight because it's a line. So here's what we're looking for. If you look at my line, do we have about the same number of points above it as we do below it? How many points are above the line that didn't actually fall on my line? No, how above my line? I only see 1 that my line didn't hit. Right here. 1. Okay? How many points are below the line that didn't? 2. Okay? And that's pretty close. That's good. That's a great line of fit. Now, if we have 5 points above it and only 1 point below it, then we've done something wrong. But as long as the number above and the number below are pretty close, if not exactly the same, you're in good shape. Okay? Now, we need an equation of that line. We just tested over writing the equation of a line. What is step number 1 to writing an equation?
Find a slope.
Okay, find a slope. And to find a slope, we need 2 points. I would never recommend on a line of fit trying to do rise over run. The points are just too wacky. Okay, so we just need 2 points that are on that line. They do not have to be off the table. They just have to be on that line. So I would use 0, 0 because that's a really good point. And I would use 240 because those are 2 points that definitely fell on my line. All right, so we're going to find the slope, which would be 0 minus 40. That's y minus y. And 0 minus 2 because that is x minus x. So m equals negative 40 divided by negative 2, and m equals 20. So there's my slope. Circle it, don't box it. Now, what is step number 2? I've got the slope. I'm now supposed to... Not yet. What do I have to plug stuff into point slope? Choose a point. However, if I have a line and the line crosses the y-axis, I can speed this process up. Does my line cross the y-axis? At what point? 0. So I can go straight into y equals mx plus b form. Because y equals, my slope is 20, my y-intercept is 0. Do I need to leave the 0? No. So my line would be y equals 20x. Now last hour they picked 0, I think they picked 118, and their slope was 18. But that was close enough to be okay. All right, that was close enough to be okay. Now, interpret the slope and the y-intercept. If slope is rise over run, in this particular problem, the rise represented the money and the run represented the hours. So if our slope is 20 over 1, that's $20 over 1 hour, what do we learn from this line? She makes $20 an hour. So write that down, okay? Write that down. Server makes $20 an hour. Server makes $20 an hour. Now, the y-intercept. What is the y? The y-intercept was 0, right? So what does that tell me? She went nowhere on the x-axis, so she worked how many hours? And she went nowhere on the y-axis, so she made how much money? So what does that tell us? No work, no pay. Okay? So that's the last part of your answer. Write it down. Make sure you get down that the server, if she does not work, She does not make money, because that is the last part of your answer. All right? That is lesson 4.4.